Hello guys, this is Miss Scott here. Today what we're going to talk about is how you can find the angle measures in any kind of polygon. Um, Really specifically we're going to be looking at convex polygons, so that just means that none of the vertices or corners can cave in. What we're going to be using is this formula right here. For any polygon, any convex polygon, if you want to know the sum of the measures of the interior angles with any number of sides, so n here is the number of sides, you take 180 times n minus 2. And if you want to see a derivation of where that formula comes from, there's some great resources online. There's many YouTube videos that actually tell you where this formula comes from, but for now just take my word for it that that will give you the sum of the measures of the interior angles. Alright, so let's just use that example, or use that formula in a couple of examples here. So in number 1, it says to find the interior angle sum of the convex polygon. So a 14gon, as you can probably tell from the name, has 14 sides. So in this formula, we're going to plug in 14 for n and then solve. So if we take 14 minus 2, that gives us 12, and 180 times 12 is going to give us 2,160 degrees. Okay. All right. In number 2, I noticed that this has 4 sides. This is a 4-sided figure, or a quadrilateral. And we're just going to plug in n equals 4 into this formula. So if we take 180 times 4 minus 2 is 2, and 180 times 2 is 360 degrees. All right, and this answer right here actually leads us to the corollary of Theorem 8.1, and that just means that based on Theorem 8.1, we can say this. The sum of the measures of the interior angles of any quadrilateral is 360 degrees. So it doesn't matter if you have a square or a rhombus or a parallelogram. If it's got 4 sides, those 4 angles add up to 360. Okay, in our next example, we're going to work backwards. So we are given the interior angle sum, and we're going to figure out what type of polygon this is. Well, we know this has to equal 180 times n minus 2. So our goal here is to get n by itself. To do that, the first thing I would do is divide both sides by 180. That way these will cancel. 900 divided by 180 is actually 5. So we end up with 5 equals n minus 2. And to get n by itself, we're going to add 2 to both sides. So these here will cancel. And we get 7 is equal to the number of sides. And any 7-sided polygon is called a heptagon. So that would be the type of polygon that we have if it adds up to 900 degrees. Alright, in our next example, we're going to use that same idea there. So we got to figure out what do these angles all add up to, and then we can use that fact to find the value of x. So I noticed that this figure has 1, 2, 3, 4, 5, 6, 7 angles. If it's got 7 angles, it has to have 7 sides. So this is actually a heptagon right here. Well, I know from example 3 that these angles all have to add up to 900 degrees. So if I start over here with the x in the corner, x plus 2x plus 156 degrees plus 133 degrees plus 99 degrees plus 112 degrees plus 145 degrees have to add up to 900 degrees. So if we combine all of our like terms here, you've got 3x, and if you add all of these constants, they add up to 645. That has to equal 900 degrees. From here, we can just subtract 645 from both sides. And that's going to make these cancel here on the left. And then we end up with 3x equals 255. Lastly, dividing by 3 is going to give us x equals 255 divided by 3 is 85. Alright, so it turns out that angle in the lower left there is an acute angle. All the others look like they're obtuse. Okay. Let's look at now the exterior angles. So examples 1 through 4, we're all dealing with the interior angles. But if you take a look at example 5, those are not interior. These 6 angles here are on the outside. So we call those exterior angles. So this should actually say exterior here. All right. No matter what, whether you have a quadrilateral or a pentagon or a 20gon, the exterior angles always add up to 360 degrees. Now again, I'm not going to prove that to you. There are some great proofs as to why that is. If you do a Google search or if you look on YouTube, you can find some great videos that explain a little bit further why that is. But for the sake of this video, take my word for it. Okay, so if we look here, we've got these 6 angles. They are exterior angles. So I know that if I take this 2x and 59 degrees and 54 degrees and x and 80 degrees and 59 degrees, those 6 angles add up to 360 degrees. Again, we can combine like terms. Notice I have 2x plus x, so that will give me 3x. And if you add those 4 constants, those will give you 252, and that equals 360. So again, we can solve this. Let's take 252 and subtract it from both sides. And we are going to end up with 3x is equal to 108. Lastly, dividing by 3 is going to get x by itself. So we end up with 108 divided by 3 is 36. Alright, so anytime you have an exterior angle, always know that it adds up to 360. Okay, in our next examples, we're going to use these 2 formulas. One thing that you guys need to be aware of, if you're finding the measure of one interior angle or one exterior angle, you have to make sure you divide the total by the number of sides. So in this case, if we have a heptagon, we're dealing with 7 sides. So I'm going to just make a couple of formulas here for you to reference for future reference. So an interior angle is equal to this 180 degrees times n minus 2. That would be the total. And then I have to divide by the number of sides in order to get just one interior angle. Okay, and that's only if the figure is regular, meaning all of its angles and all of its sides are the same size. Okay, for an exterior angle, well, remember those always add up to 360, so you can just take 360 divided by the number of sides. So let's go ahead and do that. For a heptagon, we're going to use 7 for the number of sides. So an interior angle is going to equal 180 times 7 minus 2 divided by the number of sides, which is 7. Well, we know from our previous example, example 4, that a heptagon, which has 7 sides, adds up to 900 degrees. So 5 times 180 will give you 900. So if we take 900 degrees and divide it by 7, that means that one interior angle is going to be about 128.6 degrees if we're dealing with a regular heptagon. Okay, for the exterior angle, what we're going to do is take 360, the total, and we're going to divide it by the number of sides. Well, in this case, we have 7 sides. So 360 divided by 7 is about 51.4 degrees. So each of the 7 exterior angles is about 51.4. And fun fact, look at these two. If you would add up the interior and the exterior angle, well, 128.6 degrees plus 51.4 degrees, if you add those, notice you get 180 degrees. So that's a nice way for you to check if your answer is correct. They should always add up to 180 when you're dealing with one interior and one exterior angle. Okay, in our next example, these are a little bit trickier, but what we're going to do here is figure out what the polygon is if we have what one angle is. So first, in example 7, they tell us that each interior angle is 108. Well, I'm going to use that formula from above. The interior angle is equal to 180 times n minus 2 divided by n. But now I know the interior angles are each 108 degrees. Okay, so that is going to equal 180 times n minus 2 over n. Now I like to solve these by just putting them over the left side over 1, and then we can cross multiply. So 108 times n is going to give me 108n, and 1 times 180 times n minus 2 is going to give us just that. Okay, let's go ahead and distribute this 180. So we get 108n is equal to 180n minus 180 times 2 is negative 360. Okay, next we're going to subtract the 180n from both sides. So these cancel, and we get negative 72n equals negative 360. And our very last step is just to divide both sides by negative 72. So these will cancel, and we end up with n is equal to 5. So that tells us this here is a pentagon. Okay. I promise the next example is a little less involved. So now we know each exterior angle, and we know that formula is 360 divided by n. So if each exterior angle is 10, well, let's put that 10 over 1 and cross multiply. 10 times n is going to equal 360, and if we divide by 10, we get n by itself, so n is 36, so it says 36 sides, and we call that a 36gon. I know it seems kind of silly, but that is the name. Okay, in our last example, we've got the measures of the interior angles of a convex polygon are 3x, 4x, 5x, 7x, and 8x. So we're going to find the largest exterior angle. Well, I know a pentagon has 5 sides. So I got to first figure out what these add up to. So I'm going to take 180 times n minus 2, or 180 times 3 in this case. So these all have to add up to 540 degrees. So I'm going to take all 5 angles, add them up, and set it equal to 540. And notice these are all x's. If I combine all 5 of those, that ends up being 27x. So that has to equal 540. And if we divide by 27, this is going to give me 20 for x. So the largest angle, exterior angle, is going to go with the smallest interior angle. So 3 times 20, 60 degrees is the largest exterior angle measure.